Hi, 7th grade math. This is Miss V again. And in this video, this is video 2 in quarter 2, week 4, I'm going to talk to you about direct variation. I made a video last week on direct variation, and I think I maybe zoomed too fast through direct variation, and I want to take a moment to revisit it because it's a very important concept, especially one you're going to need going into either Math 1 or 8th grade math. So let's talk about the examples that I used when I made the video on dependent and independent variables. And I think we used an example where distance is equal to rate times time. And I was traveling, I think, at a rate of 30 miles per hour. So this was our equation that we had. And what we saw is that if we traveled for 1 hour, we went 30 miles. And that kind of makes sense because if I'm going 30 miles an hour, in 1 hour, I should have traveled 30 miles. We can see that in our equation simply by putting in a 1 for the time and then multiplying 30 times 1, and we get that our distance traveled is 30 miles. And I'm going to write this as an ordered pair, and I'm going to write this as the independent variable, which always comes first. It's always in the place of the x variable. And this is our dependent variable, and it always comes second, or it's in the place of our y variable if we're thinking of this as an xy pair, an ordered pair. So I also figured out that in the last example that if I traveled for 2 hours, I would have traveled 60 miles. So I have an ordered pair at 2, 60, where the number of miles I travel depends on the time I spend traveling, the 2 hours I spend traveling. And I could continue this pattern for a while and get any number of data points that would all make my equation true. So I think if I travel 3 hours, then at 30 miles per hour, I would have gone 90 miles. So I'm going to graph this situation on a coordinate plane. So I first need to label my axes. And we've been taught in the past that this is the x-axis and this is the y-axis. And the other thing I know is my independent variable always goes on my x-axis, and my dependent variable always goes on my y-axis. So I'm going to graph the hours, which is my independent variable, on the x-axis, and I'm going to graph the miles I've traveled, and let's just set a scale of 30, 60, 90. And that's real convenient with my notebook paper. So if I travel 1 hour, I've gone 30 miles. 2 hours, I've gone 60 miles. And 3 hours, I've gone 90 miles. Now, notice the nice little pattern this makes. So with direct variation, our graph will always be linear. That means it graphs like a line, and it will always go through the point 0, 0. So if you graph something and it graphs like a curve, or if you graph something and it's a line but it doesn't go through 0, 0, it is not direct variation. Let's take a look at how this plays out with the second example I did with you on independent and dependent variables. I think if I remember right, we were filling a swimming pool. So we have a swimming pool, and we've got a hose, and water is running into our swimming pool from our hose. And I think it's running at a rate of 6 gallons per minute. And so again, I can use my equation to say, well, if I let that hose run for 1 minute, I will have filled it with 6 gallons of water. So we have an ordered pair at 1,6. And again, if I let the hose run for 2 minutes, I will have 12 gallons of water in the pool. And I think you kind of get the idea. 3 minutes is going to be 18, and 4 minutes is going to be 24, and so forth. So again, we have to identify our independent and dependent variables. And we decided that the number of gallons of water in our pool depends on the number of minutes, the time in minutes. And again, our water is in gallons. So the amount of water in our pool in gallons depends on the amount of time in minutes that we let the hose run. So let's go ahead and graph this situation of direct variation. And again, I'm going to graph my independent variable on my x-axis, and I'm going to graph my dependent variable on my y-axis. And this water is in gallons, and the time is in minutes. So this is just basically kind of how to set up your coordinate plane before you go graphing anything. So I'm going to say here's 1 minute, 2 minutes, 3 minutes, 4 minutes, and so forth. And that each one of these is 10 gallons. So after 1 minute, 6 gallons of water has run into my pool, and that's just about right there. After 2 minutes, 12 gallons has run in, so that's just a little more than 10. After 3 minutes, 18 gallons has run in, which is just a little less than 20. And after, let's see, this is 1, 2, 3 minutes. After 4 minutes, I have 24 gallons, which is right here, kind of in between, I would say in between 20 and 30, just a little less than halfway. And you'll notice again that I've graphed something that can be connected by a line. So my graph is linear, and my graph goes through the point 0, 0. How do I know that? Well, look back here. If I put in a 0 for the number of minutes, I get 6 times 0, which is 0, right? So we have a point where I run the hose for 0 minutes and I have 0 gallons in my pool, 0 gallons of water. So if we look back at our graph, it meets the qualifications of direct variation. It's linear and it goes through the point 0, 0. So those are my requirements for a relationship being called direct variation. And that's it for video 2 in quarter 2, week 4.